we should have already had done since last week. We should have already had these filled out from force and all the way up to, I believe, gravitation. So the new section that we're on today is strong nuclear force. So these are the do now questions assigned. What you're going to do on these, you're just going to tell me what is the charge of a proton and also what is the charge of an electron. When you can see the section at the bottom, you will just insert your answer. Also on this one, based on electromagnetism, how should electrons react to protons? So remember, electrons are negative and protons are positive. So if you have a negative, let me show you. We have a negative with a positive. We should know opposites will attract. So their direction will be towards each other. Okay. But if you have a negative with a negative, they will repel each other. So remember that from last time. So their direction is apart. So if we have protons with protons, what do you think is going to happen? Put your answer in the section below. So what is a strong nuclear force? First, this is holding the nuclei of atoms. So remember, we have 4 of our fundamental forces, and primarily with the strong nuclear force, this is the strongest force in the universe. This is what holds the suns together and other things of the universe. So this holds the nuclei of atoms together. It's very strong, but only over very, very short distances within the nucleus of the atom also. And it has an incredible amount of energy. So if you've ever heard of the nuclear bomb, which we will get to later, this is where this certain type of energy comes from. So inside of your cheat sheet, we're going to have in the particles affected section, nucleus, protons, and neutrons. In the range section, we're going to have very short and within minutes. Okay. All right, so what is a strong nuclear force? This counters the push of electromagnetism. So electric repulsion of protons, and this will strain the nucleus, okay? So basically when you have multiple charges inside the nucleus, you can have them repelling each other. But this doesn't really, you don't need to know too much of this. Just know that these atoms inside the nucleus can split. That's all you really need to know, is that the atoms can split and they can push against each other, okay? So this is what that force is, and it's very strong, stronger than gravity. So what is strong nuclear force? It's 137 times as strong as electromagnetism. Remember the force that keeps our hands from sliding through each other? That is 137 times strong as that. It's 1,000,000 times as strong as the weak interaction, and it's 10 to the 38 or 100 undecillion times as strong as gravity. So if we think that it's really hard to jump, well, it's really, 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 really hard to split an atom. So what is weak nuclear force? This is responsible for nuclear decay and turns protons into neutrons and back. Therefore, it controls the identity of elements, and it's weak and has a very short distance and range. So let's get more into this next. So these are, remember guys, the main things that you're writing is the objects that are in yellow, unless I say otherwise. Let's go next. All right, so this is the next section that you need to write inside of your cheat sheet, which is the particles affected for weak nuclear force and the range. So the particles affected for a weak nuclear force is a proton and a neutron. And the range of this is very short, and it's only within protons and neutrons. All right, so next, main things you should know about the forces also are that the strong nuclear force is the force that holds the nucleus together, and the electromagnetism force deals with electricity, chemistry, and light. Weak nuclear force deals with um, deals with making a proton, a neutron, and gravitational force deals with mass. Let me hide the tools. Pulls mass together. It pulls matter together. So it deals with mass, and if you have an object that has mass, it will form a warp in space-time. So um, remember what I said earlier, or last week. If we have the sun inside of a trampoline, it will cause a warp in that trampoline. Or let's not say a sun. Let's say we put a block of iron or something heavy like a big dog inside of a trampoline. That trampoline's going to bend a little bit, which will be the same thing as what is happening with the universe whenever we put an object of mass. So if we're putting that object like the Earth inside of space, then that space is going to warp a bit, and everything in it is going to want to push towards the inside of that. All right, so moving on. So we will be making a poster later on. So it's going to include your strong nuclear force, electromagnetism, gravity, and weak nuclear force. So this poster will only be on Microsoft Word, essentially. So it'll look like this. You don't have to really have it as big, but just have it landscape, and we're just going to include these main things. Okay. But this is, I'm going to give you guys further instruction on this tomorrow. And the assignment for today is on the hub, you're going to check the 101920 folder for the Fundamental Forces Quizlet. And then you're going to turn in your grade on the Fundamental Forces Quizlet section to be graded. Okay. All right.